Welcome to this video on kinematics, where we're going to find the acceleration and the displacement of a car that starts at rest. Tesla claims its new Roadster will go from 0 to 60 miles per hour, 26.8 meters per second, in as little as 1.9 seconds. In part A, we're going to find the Roadster's acceleration. In part B, we're going to compare this value to that of gravity to give it some more context. And then in part C, we're going to find what distance the Roadster would travel during this time of maximum acceleration. We'll start by finding the acceleration. But before we do that, it's always good practice in physics to write down your variables and draw a diagram. A typical kinematics question has 5 variables, but you don't have to memorize these. You can just read the question and use it to prompt you. So Tesla claims its new Roadster will go from 0. So it's starting at 0, so that's a velocity initial equal to 0 meters per second to 60 miles per hour. So we're going to work in meters per second today, so 26.8 meters per second. That would be our final velocity. It's the velocity we're getting to, 26.8 meters per second in as little as 1.9 seconds. So our time is equal to 1.9 seconds. Find the Roadster's acceleration. So the acceleration is our unknown. And we also know that in part C, we're going to be looking for the distance. So we can write down the distance, and it's also going to be one of our unknowns. And on the right, we'll just draw a little diagram. This is a great way to stay organized, especially when the questions start getting a little more complicated. So here I have my little green Tesla. We have a VI equal to 0. And then 1.9 seconds later, we have a VF equal to 26.8. So we'll add the time in here. T is equal to 1.90 seconds. We'll add our acceleration to the car here. A is equal to question mark, because that's what we're looking for. And then we also know that in part C, we're going to be looking for the distance traveled by the car, so we can add that in here too. It's time to check our formula sheet and decide which kinematic equation we want to use. If you've set up your problem like we have, it actually makes solving the kinematic equation very straightforward. First, we look at the variables we have. We have VI, we have VF, we have T. We're looking for A. Most importantly, we don't have D and we're not looking for D, so we can just cross out the equations that have D in them. This kinematic equation has D in it. This one also has D. And this one has D. That leaves us with this kinematic equation that has the 3 variables we have and our unknown A. So let's write this equation at the top of our page before we fill in numbers. VF is equal to VI plus AT. We're now ready for numbers, so let's go ahead and add them in. VF is 26.8 meters per second, 26.8 meters per second, which equals our VI, which is equal to 0 meters per second, plus our acceleration, which is what we're looking for, and finally our time, which is 1.9 seconds. And now we're ready to solve for our A using algebra. So let's first rewrite this without the 0, because it just makes it look more complicated than it really is. So 26.8 meters per second equals acceleration multiplied by 1.90 seconds. The 1.90 seconds is multiplying the A, so we have to apply the opposite to get A all alone. So we divide both sides by 1.90 seconds, because 1.90 seconds divided by 1.90 seconds is 1. So here, on this side, it cancels out. This leaves us with just A. On this side, we have 26.8 meters per second divided by 1.90 seconds. And this gives us a value for the acceleration of 14.1 meters per second squared. So we're done. We've found the acceleration of our Roadster. But before we move on, let's just pause really quickly and look at how we took units of meters per second divided by seconds and ended up with units of meters per second squared. So we're all clear where the units came from. The easiest way to do this is think back to some of your fraction math. So on top we have meters per second and we divide this by seconds. Now if you remember from fractions, we can turn any whole number into a fraction by putting it over 1, because Anything divided by 1 is just itself. Seconds divided by 1 is seconds. And now you're ready to just use your favorite technique for dividing fractions. I prefer kiss it and flip it. So we kiss it with an x and we flip our second fraction. This results in a new fraction multiplication of meters divided by seconds multiplied by, we flip this, 1 over seconds. We multiply across, so meters times 1 is meters, and seconds times seconds is seconds squared. And this is where our units of meters per second squared come from. In part B, we compare our value for the acceleration of the Tesla of 14.1 meters per second squared that we found in part A to the value for the acceleration of gravity. This will allow us to give the acceleration some context. To do this, we'll simply divide our acceleration that we found for our Tesla by the acceleration of gravity. So this equals, our acceleration of our Tesla was 14.1 meters per second squared. And the acceleration for gravity right up here is 9.81 meters per second squared. Doing this division gives us 1.44. This means the Tesla accelerated 1.44 times as fast as gravity. So if you were to drop your pen right now, the Tesla is accelerating almost 1.5 times as fast as that pen drops to the ground. And finally, in part C, we calculate the distance the roadster would cover during the time of this maximum acceleration. Because we already have our variables down the left and a diagram drawn on the right, we can hop right to the kinematic equations to choose the equation that we want to use to solve this problem. Now, as we have 4 variables and only one unknown, it really opens up our options for which kinematic equation to use. Essentially, it just has to have the value we're looking for, the distance. So this equation has a d, this equation has a d, this equation has a d. So the only equation we can't use to solve for our distance here is, well, the equation that doesn't have a d in it. It is, however, considered good practice when doing physics problems not to use a value that you've calculated along the way, because if you made a mistake here, you're going to carry that mistake through on your next calculation. So if we look at the equations and try to find one that doesn't have acceleration in it, but has our VI, VF, and T, it means we're going to use this equation right here to do our final calculation. So our distance is equal to our velocity final plus our velocity initial over 2 multiplied by time. And we're ready for some numbers, so let's fill them in. We're looking for our d here. Our velocity final is equal to 26.8 meters per second. Our velocity initial is equal to 0. We divide this by 2, and we multiply it by our time, 1.90 seconds. We can clean this up a little bit by rewriting it without our 0 term. So we have 26.8 meters per second divided by 2 multiplied by 1.90 seconds. 26.8 meters per second divided by 2 gives us 13.4 meters per second. We multiply this by 1.90 seconds. Completing this multiplication, 13.4 times 1.9 is equal to 25.5 meters. Let's confirm our units, our seconds on top, cancel with our seconds on the bottom, leaving us with our unit of meters. So what distance would the roadster travel during this time of maximum acceleration? It would travel 25.5 meters. Thank you for watching this video, where we use 2 kinematic equations to explore the acceleration of a car from rest.